Good afternoon. I am Alba Garbi, technical leader of the GBI project at IDIADA site, and I am going to present you an overview of the Green Vehicle Index initiative. The partners of the GBI consortium include a unique mix of mobility clubs, independent testing facilities for research and certification purposes, and consumer organization, which provides an extensive expertise and knowledge in the automotive file in different perspectives that are essential to achieve the goals of this initiative. IDIADA is the project coordinator, and the FIA is leading the project in the technical perspective. The project is 100% funded by the European Commission, with a total budget of around 3 million, representing a total effort of 170.5 man-months. The project started on June 2019, and it's ending February next year. So we are now in the last stage of the project. So before going into detail with the GBI project, it's important to understand the context of it. The Green NCAP Consortium started its activities in 2017 with the aim of providing a star rating on environmental performance of vehicles with the same principles as Euro NCAP safety program. So until 2019, where the program was released to the media, the consortium worked on the development of test protocols, rating methodology, and released the first batch of 12 vehicles. So with the GBI, Green NCAP will be able to enhance its initial methodology together with the requirements of the GBI grant agreement and test and rate 49 vehicles funded by the Commission. So GBI is to be an instrument for a fully fledged and self-sustained Green NCAP program, which will help consumers, authorities, and all the relevant stakeholders to identify if a vehicle is truly clean and energy efficient. So the aim of the project is to orient consumers towards the most environment-friendly vehicles by providing an independent, transparent rating and understandable information to consumers, and also to spark competition among manufacturers to really produce clean and energy efficient vehicles. So for that purpose, the goals of the GBI are to develop a testing program for the assessment of vehicles and its sustainability going beyond the state of the art and the type approval requirements, and also to define a holistic scoring methodology and independent rating system, and validated with the testing of 49 market representative vehicles. The vehicles to be tested has been selected considering 3 categories: best-selling vehicles, important segment markets, and vehicles with alternative propulsion systems. And also, as an objectives, are also to provide recommendations based on the gaps identified to enable rule makers to update future regulations or environmental policies. So the project is structured in 5 working packages. The working package 1, led by ICRT, which is the definition of the scoring methodology. Working package 2, led by ADAC, including the update of the laboratory testing procedures and the validation testing. The working package 3, led by UTAC, deals with the real-world testing procedures and also the validation testing. Working package 4, led by OEMTC, which consists on the update of the roadmap until 2030 and the exploitation and dissemination of the project. And working package 5 is the project management itself. So the main assessment principle of the GBI project is that the vehicle's propulsion unit shall to be clean and energy efficient in every feasible engine speed and engine load operation points. So GBI aims to cover a wider range of engine operation points than those evaluated during type approval testing, in order to evaluate vehicles in a more representative way and closer to the real conditions that a consumer might face on real behavior. So the vehicle should be robust enough to be energy efficient and low polluting in all its possible performance. As seen in the plot, with WLTP and RDE sample points, not all the range of the engine load is covered. So we try to cover also these non-evaluated areas, that is the green area that you can see in the plot. However, the vehicle shall not only be robust in its entire engine map, but also in different ambient conditions. So we perform the lab testing at 14 degrees, which is a temperature more representative around Europe. And also we covered cold start testing at -7 degrees test. Here is an overview of the testing matrix applicable. In lab conditions, we perform a WLTC cold start engine at 14 degrees, also the WLTC cold start engine at -7, and a repetition of the WLTC call with the PEMS installed on it, with the purpose of validating the PEMS before going to the road, and also for repeatability purposes with the first WLTC call. So to evaluate the robustness, in lab conditions, we perform a WLTC warm engine and also a VAV 130 motorway test developed by ADAC, which includes motorway driving at 130 kilometers per hour and full pedal acceleration. In real world conditions, we perform 2 repetitions of a PEMS regular cold test with the vehicle in default mode. This test is done with auxiliaries in normal use, that is lights, radio on, and air conditioning at 23 degrees. To evaluate the robustness in this part, we perform a PEMS light and a PEMS heavy load test. The first one is done in eco mode, if available on the vehicle, driving in a smooth and efficient way, and with the air conditioning switched off and minimum payload. The PEMS heavy is done in a sport mode, in case available on the vehicle. And it is driving in a more dynamic way with the purpose of covering high engine loads, and also it's done with maximum payload. Furthermore, we also perform a congestion simulation to evaluate the performance of emissions in these frequent situations on urban areas. And also we evaluate short urban trips. An engine curve mapping is done only for analysis purposes, in order to evaluate if the complete performance of the vehicle has been assessed within this testing matrix. Regarding the pollutants to be measured on lab, we take a CO, CO2, NOx with the split into NO and NO2, hydrocarbons, methane, particulate matter, and particle number, and the non-regulated ammonia and low-gen gas N2O. In real world, we measure CO2, CO, NOx, also with the split into NO and NO2, and particle number. Here you can see an overview of the rating system. It is composed on 3 indexes: the clean air index, leading with pollutant emissions; the energy efficiency index, which rates the energy consumption of the vehicle; and the greenhouse gas index, that takes into account the global warming harmful gases, CO2, methane, and N2O. The rating goes from 0 to 5 stars, and also consider half stars, so the range is spread from 0 to 10 positions in order to provide sufficient resolution within the available technologies. This scheme is designed to be applicable to all the available propulsion systems, and the thresholds defined for the punctuation are technology neutral. That is, that the limits are the same for all kinds of technologies. So to finish with this slide insight to the GBA project, I would like to highlight that the first 24 vehicles were released 26 November last week. So you could access them through the GBA project website and also in the Green NCAP website. And the next batch of the remaining vehicles will be released on February. So please, if you would like to stay informed about the GBA project, do not hesitate to subscribe to the newsletter on the website. So thank you very much for your kind attention. Also, if you have questions that might emerge after this conference or topics of discussions, you can contact directly to my email that it's shown in the screen right now, and I will be pleased to have a fruitful conversation on it. Thank you.